Hey y'all, it's Couch here, and in this Tidyverse video, we're gonna be going over some data science packages from the Tidyverse. I just recorded the Tidyr and dplyr video, and now I'm working on these lesser known packages, specifically Readr, Stringr, Forcats, and I'm also gonna use a little bit of ggplot2 just to show the examples because Forcats isn't a great package to have just as tables. So I figured ggplot2 is a good way to highlight what Forcats actually do. These four packages, the most important package is obviously ggplot2 with the actual visualization capabilities, and it's obviously made for it. But Readr is a package you kind of have to use to read in your data. Again, there's not a lot of actual functionality in Readr. It's mostly just reading in data and writing in data. Stringr again is pretty useful, especially since generally you're gonna work a little bit with string data. And I figured I'd go over the main functions of it. I'm not gonna go over regular expressions because frankly I'm terrible at regular expressions. I think it's like programming in cursive. So I don't really use regular expressions, but I can kind of go over the basic uses of it. Basic filtering and stuff like that. And then Forcats, I'm going to go over just a few of the functions that I use a little bit, and the functions that I kind of use a lot in modeling. And I think also ggplot2 will be able to be a good way to actually show the actual we'll be able to show Forcats in practice. So again, this video is going to be pretty ad hoc again, just because I wanted to do this video as more of a kind of an EDA standpoint, and also kind of explore many of the main functions and kind of get a higher level, more casual overview and explanation of these functions and packages. So Tidy Tuesday, I'm gonna call this, I guess, like Tidyr for Stringr and Forcats. Okay. I'm also going to set my working directory to scripts. Okay. Okay. Let's go back here. So with Readr, the main thing is read_CSV. One of the main reasons why I like to use read_CSV over read.csv is if it frankly parses the data a little bit better, and I just kind of like it better because I think it looks cleaner. So let's actually go into our thing, and maybe do we have any data? Okay, we can just say df read csv data byte data.csv. Oh, oops, I'm gonna specify my. I'm gonna load in the here package just because I like to use here, so I don't have to rewrite all of my directory. So again, we have read_csv. It just reads in the data. There are a few things we can do. We can specify the delim. If we like delimitation is equal to it could be like commas or dash ends and stuff like that. Generally it parses it pretty well and it's able to detect it. So I generally just kind of leave it as is. And then you can specify whether there are column names or anything like that. So if you say like columns, actually I'm gonna read CSV column names, you can say true or false. Column types, you can specify the column types. All this stuff I just don't do. I would rather just specify it in my data cleaning section than the actual reading in section. So yeah, and that's because mostly I'm pretty lazy about it, and I don't want to type all of it out because oftentimes I'm changing data sources and changing data queries, so it's easier for me just to specify in a in the actual analysis and data cleaning part. So we can also go into write CSV. Again, this isn't that interesting. I feel like it is important that we know this type of stuff, but it really isn't that interesting. So again, we can say write CSV or write underscore. So write CSV, we specify what we want to do that. We specify the data, and then we kind of give it, the file name, which is like test.csv. I guess you can also say append. So if you already have an existing file, you can say append equals true. By default, it's false, so just overwrite it. But again, that's basically it for the write CSV. True. So yeah, that's the Readr package. I wanted to include it in the video just because I see some people using read.csv and then running into like encoding errors and stuff like that. And I find that read_CSV generally handles it a little bit better. But other than that, again, very straightforward package. I feel like I've already spent too much time going over how to read in data, because it is straightforward. Okay, so now we're actually going to the Stringr package. Obviously we're not going to do a lot of like text analysis and stuff like that. But I think I'm going to go over mostly like str detect. So str detect is probably the most useful function. So if we actually go here, and we're just going to use this data set. Often we're going to use filter, and we might say like method is equal to ko tko, right? But sometimes we run into errors where there might be spaces on it and stuff like that. So one thing that we can do, right, is we can actually clean our data by using str squish. And then we can, what I usually do is str trim. Oops. Equals. Oh. str trim, and what this does, str squish basically, it removes the spaces on front and end, the start and the end of the string. So oftentimes when you're like at a database or someone's like manually entering in data, and specifically text data, they might accidentally add in an extra space at the end or at the beginning. And then when you say filter gender is equal to male, and you don't get any rows back, it's because there might be a space. So I generally will always do str squish with an str trim to remove any of the extra spaces, both on the front and start and also the duplicate spaces, because I find that causes a lot of issues when you're doing a lot of like filtering and manipulation like that. So that's how you basically clean most character data. You can also do str to title, which will kind of, it's like the to proper in Excel. So in this case, we wouldn't want to do that to there, but maybe with like fighter, we might do str to title and give it to a fighter. And it'll kind of convert it. I think I already have that converted, or might be already just done like that. But those are some basic, string cleanings that I will generally do. Again, with once we have all these spaces removed and stuff like that, what we can also do is like do a na if. So if there's any just missing space values that have like no values in it, just a space, we can convert that into an na. So if we actually, let's see if I can actually do this right here. And I'll just give it, it's like the dog, right? We can see how the dog is n. We can also right there, doesn't even change, doesn't change. We can also say like if it's just an empty space, it'll convert that. So then when we do the NAIF, it'll change to NA. Right? So so that'll change it to an NA if we have any like missing values, and that's pretty useful too. So I think NAIF also, let me check this. NAF is from dplyr, so again, pretty useful thing too. But you can also do a mutate if else statement too. Okay, so one of the more common things I do when I'm filtering for strings is I'm never really gonna do like filter and say fighter is equal to Derek Brunson. Generally with strings, I try to do an str detect. So I'll say like str detect fighter, and then Derek Brunson. For me, I think it's a little bit easier. Plus, you can use regular expressions. But in this case, we don't really need that, so we can say detect, and I'll still find that, and then Derek B, and I'll find Derek Brunson like that. So yeah, str detect, and then str squish and str trim are very useful functions when you're kind of cleaning up the text data. But again, once you get really into like pattern detection and stuff like that, that's when you kind of have to go and do a little bit more research on regular expressions. Okay. So once we actually have, say, like all of our character data or text data cleaned, we generally convert them to like factors or something like that. And Forcats is kind of the package to do it. So in this case, let's see if we have, yeah, okay. So I'll just say, I'll select the weight class. Let's see here. I'll do, I don't know, KD strikes landed, sig strikes landed, takedowns, and then sub. We'll just do strike landed. Okay, so we have these. I'm just gonna separate weight class. See gender, weight class. Separate based off the what? Separate based off the little underscore, so that we have this. So one thing we might want to do is, let's just do a ggplot AES x equals weight class. Actually, we'll just first do a group by. So group by gender, weight class, summarize, and we'll say, I don't know, strikes landed. Strikes landed is equal to mean strikes landed, or maybe we'll just do median. So median strike landed. Maybe do an NA dot. True. Okay, so median strikes landed. Again, we kind of have a cool little table. We can probably plot it out. Right, so pretty cool. We can do a chord flip. Yeah. So we have that, but if we notice something, we notice that, these weight classes aren't in order. We kind of would probably want them in order. Additionally, there are some things where like maybe we don't want catch weight and stuff like that. So let's actually go back and kind of mess with this data. So one thing we can do is we can just filter it. So weight class does not equal to what to say. We'll actually use the str detect weight class, and then we'll say catch, and we say we do not want that. So we have that. So we no longer have catch weight. Actually, I'm gonna do another thing too. I'm gonna say mutate median strike landed is equal to if else gender is equal to men median strike landed else. That way they're flipped. Okay. So we have that. And one thing that I kind of like about Forcats is that it's pretty useful when you're doing a lot of ggplot plotting stuff. With Forcats, if we go back here, it's all about handling categorical or factors. So let's actually go back to the reference, and we can kind of change it. One of the main functions we can use is that, let's say weight class. Weight class is equal to facet you can say re-level, or you can say facet. Actually, we'll say facet reorder, facet, and then we can say we want to, you know, arrange it by median strike landed, right? Actually, yeah. So we can do that, but one thing we might want to do is actually do like a custom facet. So I'm gonna actually just do that. So let's actually go through here and specify. We can specify our actual classes. So in this case, I'm actually just gonna use some case statements. So weight class is equal to weight class order is equal to case when, and actually I'm gonna pull up the UFC weight classes. Right. So I'm gonna say STR. I'll say weight class is equal to straw weight. Then 1. Okay. And then we'll say was it flyweight? So we have our flyweight. And then we have our bantamweight. Then we have our featherweight. Then we have our lightweight, middleweight. Wait, no, it's welterweight. Okay. Welterweight, middleweight. Where's our heavyweights? And then our heavyweights. Okay, so then we can just kind of change that. So 3, 4, 5, 6, 7, then 8. I want to make sure weight class is not found. Oh, weight class. Okay. Now I'm just gonna do a little sanity check. So weight class, and then weight class order. Flyweight when weight class is equal to straw weight. It's here. Arranged by weight class order: straw weight, flyweight, bantamweight, featherweight, lightweight, welterweight, middleweight, heavyweight. Okay, sweet. So we have that. And then what we can do is just say, you know, weight class is equal to facet reorder weight class function weight class order. Right. And then with that, we can actually plot it out, and it should be in order. Right. So straw weights, flyweights, bantamweights, featherweights, lightweights, heavyweights, etc. Pretty useful right there. One of the more useful, another useful function too, is we can kind of look at, let's see here, count method, right? Sometimes we're working with pretty sparse levels, right? So if we actually do a sort equals true, we can see like 4 is other, could not continue, DQ, overturn, TKO, submission, KO, TKO decision. Basically, overturn, DQ, could not continue, other should kind of be lumped back into other. So what we can actually do is mutate method and say facet lump. And there's many ways to do it. There's low frequency. There's min, where you have to have a specific amount of levels. You can just specify the levels, I think, the number of levels you want. Yeah. And most frequent. And then proportion. So we can also, for me, I'll say, I don't know, we'll say low freak in method. And let's see if it actually does it by auto. And we can see it kind of just does it right there. Low freak. So let me go back to, we can kind of actually go into the actual facets. So lump, low freak, lump n, lump min. Low freak in the least frequent level, ensuring other is still the smallest level. So maybe that's why it's doing that. And then we have lump n, all levels except for the n most frequent. Lump that appears fewer in prop times, and then min. So there's definitely a bunch of ways we can do this. In this case, we kind of just want everything below 160. So facet, lump, facet, lump, low freak, and then lump min. Oops. Min method and equals 160, right? What is it? Lump min. Oh, it's min. Count method. Oh, oops. There we go. 161. So that way we can kind of lump it, right? Where if you need to get at least 161, or also just lump everything together. Cool. And then once we have that, right, we have our other, we can kind of just plot it out. So x equals method, y equals n. And then we can see like most of it goes to decision, KO, TKO, submission, and then other, which are like disqualifications and could not continue and stuff like that. So again, pretty interesting, pretty useful stuff too. If we really want to do another thing too, we can kind of go over one more function from facet. Oops. So we notice like fast other, we might want to put other right there, right before decision. So we can actually say like mutate method facet relevel, and then method, and we say was it other decision, and then just copy this in, right? So that way other is at the beginning, even though I think visually it doesn't make a lot of sense, but you know, it's something where we can kind of specify where we want our visuals or for our categorical variables to be at, which is definitely pretty useful when we're doing a lot of like very important plots that we want to maybe like show on like an article and stuff like that. So that's basically it for this video. I know I went pretty quick, but Tidyr, Stringr, and Forcats definitely have important functions, but they only have a few, but they are used a lot. So I just want to do a video kind of doing a high level summary of all of the 3 packages and, you know, the main things you would actually use from it. So with that being said, I hope you guys enjoyed the video, and I'll see you guys next time. So tidy on.